Lunch speaker, Sami Mitra from PRL. So he will give a very interesting talk. Please, Sami.
Right, thanks. So this is just it's lunch. I really can't go on and on. People will get bored. So it's just a few things that I've been thinking about. It has nothing to do with the journal, nothing to do with PRL. If you have questions about PRL or how to get your wonderful stuff published or rejected, come and talk to me. I'm here today and tomorrow. So these are just, we're playing this game, publications in physics, all kinds of good stuff. But, the scenario is changing. And so these are just some things I've been thinking about. I've presented them before. And just food for thought, right? Something to chew on. So, all right. So this is not getting forward. It was earlier. What's going on?
Click on the project presentation.
It's happening, all right. This one is not working. It doesn't matter. In fact, if this works, then it's good. All right, so I think only 2 slides, so it's okay. If I can get to the 3rd slide, it'll be fine. So the first thing is, this is actually, I don't know, it's not sure if folks in this room consider themselves to be physicists, chemistry, material scientists, machine learning experts. I'm guessing no. But anyway, so the question is, in the world of PRL, in particular, a journal such as PRL, one of the challenges we have is the definition of what is physics is A, changing over time, and B, differs from field to field. So for example, to give you an example of changing over time, we had talks on graphene, twisted Morris systems, TMDs, and so on. When some of these things first came into fruition, so to speak, it was clearly in the world of physics, right? People were studying them, the initial Nobel Prizes and all that kind of thing was in the world of physics. But have you moved forward? When I go to some conference on, graphene, for example, I would argue now maybe less than a quarter of the people there come from the world of physics. So clearly, more material science, more chemistry than physics, I think, today. So there's clearly a sense where something which was considered physics has kind of moved away and morphed into other areas, which is fine. It's good. That's the way science develops. But if you're at the end of the day considered to be a physics journal, and particularly a basic physics journal, then you have a problem with that, right? In other words, your interfacing of Venn diagrams with that world is maybe not quite what you want to be. And the other thing is it differs from field to field. So if I was making that statement in a room full of lattice gauge theorists, for example, or a room full of people doing nuclear structure theory, then that kind of, is it quite physics? Is it not physics? Doesn't really come up. So that depends very much on what kind of fields you're at. If I'm talking to a room full of biological physicists, it's very different. So that's one challenge we have. So here's an example. This is a conference, and graphene happens every year. And this is the conference chair's kind of presentation of the scope of the conference. And you can see all kinds of fancy buzzwords, optoelectronics, biotechnology, and so on. The word physics does not appear in. So that's how it was, and this was very different, would have been very different 10 years before this. All right, now they're going on to these questions I had, and this is just a single slide. I could stay on this slide, but I have a couple of slides later, which are just broken up into this. So let me just move into that. The current landscape, what are some of the existential problems we're going into in this world that you guys are playing? And unfortunately, at the end of the day, you do your research and all that wonderful stuff, but kind of the publishing of paper is still kind of a central equation of the whole enterprise here, right? So the first question is, peer review as we understand it today has been like it is currently for, I would say, 50 plus years, right? You submit a paper, the expectation is you want to get it in a peer-reviewed journal. Used to be, I would say, as maybe 25 years ago, the role of the journals was to get it out. Dissemination, no longer the case. Every paper we receive in PRL, in pretty much every area, has often been on the archive for weeks before it's even submitted to the journal, let alone before it's published. So the fact that you don't need the journals to get this out to people, right? So that's not the, So, and there are areas, like machine learning is a good area where they don't believe in journals. And so often the research sits on some kind of data repository, often a data repository, and that's considered good enough. But in certain areas, certainly in certain types of physics, journal publication is considered to be, what is still needed. And that goes with this peer review. I think what differentiates the journal from a non-journal is peer review. The peer review, as we have it now, doesn't have to be forever. There was a time as recently as the 30s, there's a famous anecdote with Einstein. We can talk about it if you're not familiar with it, where he submitted a paper to physical review, pre-PRL, and was irate when the journal had the temerity to send it to reviewers, because I guess his position was, I'm Einstein, I'm sending this paper, who are you guys to get it to ask somebody else. So that tells me that at that time, there were famous people, and the expectation was, we don't need no peer review. But somehow today we're in this world of peer review. It's entirely possible that, as soon as 20 years from now, some kind of algorithm selection, booking.com type sorting mechanism will be good enough that most researchers will not value peer review as we understand it today. Possible. All right, so the other question I have, and things I'm thinking about is, metrics, right? We were talking about it just today with somebody with DOE related stuff and promotions and so on. So when you have some faculty member about to get tenure or somebody coming in and you want to hire this person, there are, these H indices, impact factor, and all kinds of considerations, which are pushed forward by journals, and other entities. But it's not because the journals are doing it in isolation. They're doing it because there's a sense that funding agencies, hiring committees, tenure committees give certain importance to these kind of metrics. I mean, this was not the case at this extent 30 years ago, 20 years ago, right? It is today. I don't know if it'll be like this 10 years from now, right? Something else may come along, some other better filtering. So for example, social media is another question. I mean, as recently as I would say 10 years ago, a lot of importance was given to altmetrics. I hope you're all familiar with it. It's some kind of metric as to how your published entities play in the world of social media. Altmetrics, Twitter, X, all of this, it seems today that the importance was overemphasized as recently as 10 years ago. I don't think you're making hiring decisions based on how your applicants' papers are featured in social media. It's, that may change. There is this funding thing, which is always, the journals talk about it. This is an ongoing thing. Different countries think about it differently. First, the concern is every paper that's currently published in one of these journals, subscription journals or open access journals, are pretty much available for free. Authors are free to put any paper they submit to any of the PhysRev journals on the archive. And they could sit there forever for free to download. Google Scholar gives you all the links you need to all the PDFs. So why do people still pay for this? That's one question. How will the financial models work out? Open access versus subscriptions. I don't know what people in this room feel about open access. But one question to consider is that open access has been considered the model of the future. However, the push for open access has largely come from the global north. So if you think about countries that have pushed for open access, that think that open access is the way of the future, there are certain countries for whom it's not necessarily a financially equitable model. So that's something to think about. How this plays out in the coming decade, I don't know. And I'm guessing most people don't. All right, the other thing I want to talk about, just a food for thought, is what is a paper? Again, in the world of science, we're kind of behind the times, right? So what we consider to be a paper today is essentially a paper which exists as an electronic entity we call a PDF, which is printed, published online, and has a date stamp on it. And that is kind of considered to be a frozen in time kind of entity. It's very different in the world of other kinds of publications. So for example, a newspaper, New York Times, for example, we are in the US, most people are familiar with it. If I posed a question to any of you saying, what was the New York Times today at 2 a.m.? It has no meaningful answer unless somebody took a screenshot. There's no way for you to recover what it looked like at 2 a.m. There used to be, as recently, or even in the printed edition. We get the printed New York Times at home. It's printed out of a printer or somewhere in Queens at like 1 a.m. So by the time it comes on my breakfast table, it's already outdated. Everything that is in there, I may have read days before or this morning. So the timestamped version, really, the newspapers have moved away from. So, but in the world of physics, we still consider this to be a static PDF to be the end product. We don't think of it as a living entity. I can imagine a journal article being some online entity that is kind of like the archive, but not the full PDFs being replaced, just constantly changing over time with some kind of footprint mechanism that, that's the article. And you just add to it. You don't have to keep publishing different papers, every few weeks in some cases, just to get the next iteration. It could be just a growing thing. We haven't reached there yet. There's no, reason to think that that will not be the case. All right, getting to the end, some other things have come into, and so one thing is artificial intelligence, which plays a big role now. Unknown what role it will play.
You say, this new version of the paper, you can add to it. Do you think people will delete from it? And
as long, I think there's, if it's, people now, there's the whole concept of retraction, right? So think about retraction. Used to be, in the world of paper, if you publish something and then you retracted it, nobody would know because there's no forward linking, right? So you publish something, it was retracted, or a comment appeared on it or something. 3 years later, no way to know. You would only know it because you happen to know it because of, but just by looking at the paper. Now you do. So I can see some situation where, wrong parts of it are taken away with some kind of link saying this was removed. We can imagine that, as long as there's enough of a footprint so that missteps are not completely hidden, that can happen, right? So that's one way to think about it. Or you just have, collapsible entities which don't appear in your first view and then they appear as you go down the weeds. AI content creation, we were discussing this last evening. We talked about revising papers, formatting papers for this journal in 4 pages versus that journal in 15 pages. I bet 2 years from now, you'll write a paper for one journal, 4 pages long, and you'll instruct ChatGPT to render a version for you friendly for some other journal that'll be 12 pages long, and it'll do a wonderful job. And in this case, what I'm saying is wonderful is defined by the humans, in this case, the referees or the editors' ability to decide if a good job was done or not. And if it's beyond their ability, it's a good job. I can see the reverse is probably going to be much quicker, which is you write a, nice PRB, and you say, maybe this should be a PRL. Please condense it into a PRL ChatGPT, and it'll do it. And the question is whether editors and referees will be able to find that to be problematic. Is there going to be an algorithm, human or otherwise, that will say that this is problematic? If not, then that's the way people will do it. Searching, we already have the ability to do an immense amount of literature search and all kinds of other stuff using artificial intelligence, large language model driven algorithms, which are extremely good. If you haven't tried it out, give it a try. Filtering, same thing, searching, those. So the other thing is now connected to that, we've kind of made a push for it recently. Others have also the availability, transparency, and reliability of data. I think the world of science, world of physics has always been kind of behind the curve on this. It has been, as we know from recent cases, but this is, so if you, for those of you in this room who remember Schoen, for example, and you draw a line from Schoen to the recent high pressure superconductivity scenarios, one can argue what changed, what had changed in the meantime. So I think some of this has to do with the ability for large numbers of people to just look, reproduce, and play with the data. Some of it is technological, which is getting easier, but I'm guessing this will all, the transparency and availability of data will become easier over time. So that's something we have to. Now, coming back to this, and I think this may be my last slide. Also, the same things have a flip side, which I hadn't thought about so much before, but recently, so there's questions about academic fraud, ethics concerns. I highly recommend, any of you here listen to Freakonomics Radio? Freakonomics recently did several, they've done it earlier in the year, and the last few, they did a couple of episodes of academic fraud in other fields, not so much physics, but they also mentioned physics, of course. And if you think about it, in all these areas, these arrival of these artificial intelligence LLMs make this kind of thing easier to commit, hopefully easier to detect, but unclear. So that is one part, thing. That is something the journals have to confront at some point. And some of it is fine. I mean, I think if papers come in and they were initially written by somebody not that proficient in English, and you use some software to fix it up, make it much more reader friendly, that's acceptable. If you throw some data at it and say, make me a bunch of plots and give me the one that looks the best given what I want to show, that's problematic, right? So, but all of those things will become easier to do, and that's something that the community at large will have to confront. Same with reproducibility. It's easier to play with data. If you have data, you can do all kinds of stuff with it. But at the same time, it'll become very difficult to know whether you were repeatedly doing trial and error to get to what you wanted to show in the first place. I think there's that. Okay, I think I'll end here. I had some PRL specific stuff, but that's boring. I can discuss it if you want to. If you have any questions, but that's for now, that's it. Food for thought.
Any questions? Yeah, Helen, please.
Yeah, I had a question, which was, bioscience is kind of much further down the line with a lot of these issues than condensed matter physics is. And then, so they've got really serious problems, and that's really affecting NIH, and COVID is kind of really important because NIH didn't really deliver, and it was Department of Energy and other agencies actually did the heavy lifts and all the rest of it during COVID, because NIH was seen as kind of a software funding agency to some extent, because it was funding a lot of kind of crap, basically, funded by a lot of fueled by these metrics and so on. So, are you aware of what's going on in the bio side with publications?
I'm not aware. I think I mean, in a way, it's, one could say, lucky for us that the incentives are weaker in the world of physics to do fraud, right? I mean, there's much more of an incentive to do fraudulent research in the world of medicine, cloning, all kinds of, and by the same token, I think we are more likely to be asleep at the wheel in terms of catching fraudulent, but I think overall, so I'm not so sure. I think the biosciences, it is kind of, they have to do more because there is way more fraud, but I'm not sure whether what they're doing, and this is a long discussion.
What's happened is like the emphasis is on more to kind of capabilities and serious, but not about publications, it's going to actually serious capabilities and ability to kind of deliver results and so on. So, it's almost like going into the whole question of how worthwhile papers are.
Well, that's a separate, yeah. So it's a very long philosophical discussion, I think.
Well, it's there now. I mean,
Yeah, no, I understand it.
We're all at home for a year.
Yeah.
Concerning academic fraud in physics, it might be that we are overemphasizing it now, because I mean this is a story as long as the physics.
No, but
itself. Let me just finish. Remembering the N rays, after discovering of X rays.
Yeah.
Just that the question that can be analyzed quantitatively: did it scale or did it not with a number of publications? you know, there were much less publications in the NRA era, and so the fraud was quite, you know, substantial with NRAs, but, you know, now maybe the amount of.
Yeah,
fraud
I don't think that proportionately there is more fraud. You're correct.
Yeah, so,
But from the perspective of the society at large, is it the total amount or is the proportionate amount given the total amount of research? So I don't know. I think there are two. One is there is a lot more being done in terms of total research. So even if fractionally the amount of fraud has dropped, that's, you know, this total there will be more fraud. And the other thing is, you know, we're talking about data manipulation and stuff like that. It may get easier to do things like that, which is just the act of producing data is easier.
right, but that also has a direct effect and easier to produce good data. So, I mean, as a fraction
Yeah,
of
so
the
that's-
good data, I mean, maybe just scale, so we don't have
So
to
it's
be really
possible.
concerned.
Yeah. I mean, it's possible that what you think that the people producing, you know, the good guys, you know, dominate the bad guys. Possible.
Probably number of individuals what matters,
Yeah.
not the amount of data.
Your question.
Joseph.
I'm not so convinced that Schön and high pressure frauds are particularly useful ways of guiding our behavior. Because if you cross-grain, they committed fraud and they were found out
They're found.
relatively quickly. I mean, of course, I have given the room, you know, the story about that better at the time. But, you know, with Schön, the thing was that he claimed to be able to do things in a way which is very hard to reproduce. That's why it took a long time to, you know, to actually figure them out. But the great strength of our community is that we can actually believe each other, right? So we listened to a lot of interesting talks today. I wasn't sitting there and thinking, is that person just making up this data? Explanation of that. And so you'll always have freeloaders who use the fact that we trust them to lie. But I think we've got a very good track record of actually sitting out those things.
No, I fully agree with you. That's why I said I think
I think a much bigger problem lies with things like quantum information, where a lot of people in the community have a very substantial financial stake.
that's
So if you basically now have a paper where someone says, I've got quantum advantage in my experiment, in my view, then
The
that
Google
person
stock
actually
goes
has a
this.
huge
and
financial
yeah, one
I'm the
thing
bioscientist,
I did.
and I do not think we actually are guarding ourselves.
We are not, I think, and another thing I did not mention, which probably is something, you know, can talk separately, is particularly true in the world of machine learning. It's entirely possible that the frontier work, that the most advanced work is being done by proprietary companies who are not presenting their research and their data at public meetings like this, right? So we have no idea. I mean, I don't, but I think the machine learning people in the world of physics probably have no idea what advances are truly being made. I think there's an expectation in the world of science, these physicists here, which is very different from pharmaceutical research, for example, that research that is being done is being talked about at meetings and so on and so forth, and we are on top of the game because we talk to fellow physicists. That may be true of more materials, but I don't know if that's true of machine learning. It's possible that companies such as Google or NVIDIA are doing, you know, work which nobody here, even if they're working in machine learning, are aware of what they're doing. So that's a different, it's not fraud. It's just a particular, it's just the opposite of open science, right?
Okay, great. Thank you all for a very nice discussion. So we have 5 minutes, right? Before the afternoon session. Have some water or coffee.